Good afternoon, everyone. My name is Nabeel Derhem, and today I'll be talking to you about NoSQL. Just first, I have to talk about myself a little. I'm a member of DevLifeStyle, and I also have a community for SQL Server called SQL Server Path, which we discuss mainly SQL Server kind of development, DBA stuff. Okay, so what are we going to talk about today? It's NoSQL. How many of you have worked with NoSQL? I expect 0 or 1? 0. Okay, that's actually better because it will make the session more with more benefits for you guys. How many of you at least read about NoSQL? Okay, how many of you heard of NoSQL? Okay, 2 guys. NoSQL is like the new trend for databases, and to understand the big problem I found with NoSQL is that many people have their own myths about it. Nobody really knows what NoSQL is about. So I think my aim in this session is to explain to you why do we have NoSQL, what are the current technologies using it, and most importantly, to set you on the right track. Not to just, you'll be hearing a lot of talk about what NoSQL should be or should not be. I'll try to give you an idea, a real good idea, so you know where to start, or at least how to discuss it with people. I found many people, even consultants, who just tell you NoSQL and blah, 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 and you just stay quiet because you don't understand what they're talking about. That's what they want. You should know, at least by the end of this session, you should be able to talk back to them. So, to explain to you in the right manner, let's start with the problem. All technologies that we use came out to solve a problem. If you really want to understand the technology, understand first why do we use it, why we had to create it. So my beginning will be with in like the 80s, it's actually before the 80s, when we invented the concept of relational database. It's hard for many people to imagine, but there were days where there were no relational databases, and you had to work with things like text files. These actually are, in one term or another, a NoSQL implementation. So in the 80s, they started with this concept of relational. That was the new trend at the time, and people were doubting that it will work at that time. But we all know that this of course, has been the major thing for more than 20 years for storing data. Why was it so successful? It's because of the main features that it had. Persistence, which means that the data is always there and it's always in a consistent way. Bankings work on relational, right? Why? Because it works good with transactions, another concept. Reporting, integration, and stuff like that. Integration. How many of you use databases for integrating different systems? You use it, right? Because you build it for a system, and then other systems want to read from this database. So this is one of the major uses of relational database engines. Okay, by the way, usually I don't have such cool slides. I was having my own presentation, but I stole this with the approval of its owner, a guy called Martin. He had a really good presentation slides. I just asked him to use it in this session. See, this is the concept behind relational. Look at this. You have a form, right? This is what the user sees, and they fill data from anywhere. The problem is, this data doesn't get stored in one place, right? It goes to different tables. This is what we use for. But if you think about it, like from out of the box, isn't this a problem? Because you have a different view of the data in the actual location where you store it than the data that you actually deal in the application. Okay, this is they call it the impedance mismatch. This is a well-known problem, and the way to solve it is usually documentation, right? To tell you about, you use this field in this place, data modeling, and all of this industry came out just to solve this problem. Okay, the impedance mismatch. If you think about it, if you start from scratch and you knew nothing about it, this would seem like unnatural. You would think, no, I want to store the same thing in one place. Is this a good idea? Now, if you think about it, you'll start saying, but I will have this problem and this problem. This is what I'm going to discuss with you right now. So, at the 90s, somewhere in the 90s, people were saying that this is wrong. We should just store the entire thing into disk. In terms of object, we are all used to objects as developers. Developers have a big problem, and I assume you guys also have it, is that you need to learn a lot about SQL, right? Now, for many developers, this seems like an unnecessary thing. I don't want to learn how a language just to store data. I just want to use the same knowledge I learned from development and just take this thing and just put it to disk. I don't need your SQL. So at the 90s, there was some kind of movement at the end of the 90s. They call it object databases. Store the object itself. Some people thought that this will work out, but it didn't. It failed at the time. And the main reason for this, the fail, to be honest, wasn't that it's so bad. The reason was, I told you, one of the main uses for databases is integration, right? So see this. You use this database to integrate different systems, right? How can you do this with objects? You can't. It becomes really difficult to share data. And that's why, that's one of the reasons why we weren't ready at the time for kind of technology or storing data like this. So it failed out, and we ended up most of the years in like 2000 until 2010 with still relational being the dominant technology for storing data. Now, the problem started to happen when we started dealing with what we call big data. Data became overwhelming. You have too much data to store. And think about it. Usually, when you think about a database, you think about a server somewhere, right? You think about a single entity or a single machine that hosts the data. So if we have more traffic, what do? We add more power to that machine, right? But apparently, the size of data was more than the power that you could add to a single machine. So eventually you had, instead of scaling up, you had to scale out. You had to use more machines. And this is where the problem started, to show off really big. Because databases, relational database engines, are not really designed for scaling out. Think about it. It's usually a server or a cluster, right? But it's in the end, it's one thing. So this started to show off as a big problem. So instead of these big machines, one big machine, companies like Google and Amazon came up with their own solution instead by having more smaller and cheaper machines. This is how Google works. Instead of big servers, they have cheap servers, which they line up, and they let them work together. We call it grids. Again, databases, relational database engines are not designed to work optimally with this way. They do work, and I'll explain more about this. But again, it's not what I call a natural thing, and you have to modify the way that the database engine works if you want this to work well. So Google and Amazon came up with their own solutions. Google has it as something called Bigtable, which it owns so far, and that's the way they store their data or search through their data. Amazon came with Dynamo. What happened was, the unusual thing about this term is that it was too many technologies at the same time started appearing, and nobody could give a name to them, a single name. So instead of naming it with what they should be, they name it to what it's not. So they just said it's NoSQL. Some people think that this is the origin. Other people think no, the real name is an acronym for not only SQL. Okay, so it doesn't have to replace SQL. It just covers area which SQL cannot cover in a good way. The initial concept started somewhere at the end of the 1998, I think, or so. But the real rise of NoSQL came in 2009. And the funny thing about the name was it's because of this guy. This is why it became famous for this name. There was a conference that was supposed to happen in San Francisco where all the people who are having these technologies will meet together. And they wanted to share this through Twitter at the time. That was 2009. So they had to come up with some hashtag. And so somebody said NoSQL. And that's why the name caught up. Now everybody calls these databases now NoSQL because of that single event. Okay, so how do we define NoSQL? It's very hard to define NoSQL because again, it's just an opposite of the SQL way of handling data. We can summarize this as by these. It's usually a non-relational. Most of them are open source, not all of them, because commercial companies now are starting to follow up with this. But still, the main advancements so far have always come from open source community. This is one of the major things about it. It has to be cluster friendly to solve the problem, because that's the major problem we have with relational engines. Of course, it's usually for web, following up the 21st century, and this is, I mean, for me, it's two concepts that really makes the difference: cluster friendly and schema less. It doesn't follow up a schema. This could be a problem, because remember, the point is I want to store data as it is. I'll talk more about it in next slides. How can you develop a schema list? Usually, by the way, is there somebody here who's actually a database developer? Usually you have developers working with SQL, right? But sometimes you'll find SQL developers, just because if you talk to a SQL developer or a SQL admin about this, you will find them like, they will be shocked. How can you build an application without a schema? It just doesn't make sense to them. And to some of you, it might happen, but developers usually know. They think it's natural. I can define my own schema and just use it from an application. Have you tried building an application that only writes to text files? Anybody did this? You don't have a schema, right? A natural schema. You have a schema that is enforced from your application only. So you know exactly that the column should be named name, right? But this is not a schema that you configured sometime in your design time. It's just whatever you want. You want to change it in the future, it's easy to change it from the application. So that's the main concept, and the way that it's built, it's totally different. You have to start from scratch with the way of thinking. So these are some of the technologies that are currently working with NoSQL. You can see that there's a lot of databases. You can't be sure about which one will actually have a better future. It's still under debate. So you have to choose carefully the technologies you're working with. But all NoSQL technologies follow one of these four categories. Okay? Document, column, family, graph, and key value. I'm going to talk about each one, but again, remember, this is not a session to get deeply into each one. I'm going to just explain what each one means and how it deals with data. So you can then get into more depth on your own. So the idea of key value databases is very simple. You just store a key and then a value. Imagine it, if you're from a database, as something like the ID and the name. So it's exactly. This is the best way of thinking about it. It's like a hash table. Okay? A key and a value. You put whatever value you think makes sense to you. But it's usually a single value. If it has more values, you can have more values inside one string if you want. But it's like a single thing. If you think about it, this gives you the best performance in inserting data, right? Because this is one of the biggest problems when you're working with data. How fast can you insert data or scale up with data. This gives you really good performance with that. A second technology is called document database technology, which is simply think of each row as a document of its own. So it's like this. Usually, by the way, documents are written with JSON. They could be written with anything you like, but usually it's JSON. This is what they decided would be the best. So it's something like this. You have an ID, and this is the value. You have a customer. You have a line. Do you see what is happening here? What do you see from this? It's a customer, items, product. This is an order, right? An order. When you place an order, you need the customer. You need the products that they're ordering, right? So instead of saving this as separate objects, you store everything in this one document. Okay, this is the concept of document databases, and Mongo is very famous for that. MongoDB. The thing is, I'm free to add whatever data and columns I want. So here, for example, I could add something called discount code, which is not in this one. You're free to use whatever schema you like with that document. Okay? But this doesn't mean, this is also a misconception. You can't really call it just a non-schema. It's schemaless, yes, but there should be an implicit schema, right? You can't build an application without an implicit schema. So for example, when you say I want the price, then you know that you have to store a column named the price. Okay, so this is one thing. It's not without schema completely. It's just you're flexible to modify the schema anytime you want. If I want to add a new column, it's okay. I don't need to do a lot of work, as in relational database interest. So remember this. There's always schema. There's always some sort of schema. Now, one of the things that many people will get confused with, I got confused with this, is that these two look actually a lot like each other. Because how exactly are you going to access a document? It's by a key, right? But like the ID. So you can imagine it as something that both of them somehow are just different ways of saying the same thing. You can call any database. I heard some people calling MongoDB a key store, a key value, or some people call it document. For me, both of them are the same thing. Okay, just very different, slight differences in how they store the data. But think of them as something similar. I mean, the metadata here is, for example, a customer ID. It depends on what you want to do. While here the key is the ID, and the value again is over here, whatever you put. Okay. Now I have to come to a next thing, a concept named aggregate. This is very important to understand before you go on before we go on next to discuss more about NoSQL. Do you remember what we said? The order, and we put everything in it, right? Why do we do this? Because it's an aggregate, right? Usually we think about data in an aggregate form. When we think order, I'm thinking about the things inside the order with it. It's one single thing. So what you're doing is you're aggregating stuff based on your needs. This concept is very important because databases are not designed this way, right? In databases, you create entities like order, item, separate things, and then you link them up together whenever you like. The good thing about this is you can aggregate data from any angle. But the thing in NoSQL database is you usually aggregate in one way. You think about one way which really matters for you, and you put all this data in one thing. There's a book that explains this, how do you actually use aggregates, and this is a good book. I found it in the slide. I read about this book some time ago, and it's a really nice book that explains it. It's called Domain Driver. You have to define your domain. What exactly are you trying to do, and aggregate your data based on it. Now again, this is different from databases where you have something like order, line, items over here. It's different. Instead of separating these entities, what you do is you aggregate stuff as we saw here. I mean, in key value, your aggregate is what? The value. In document, The document itself is the aggregate. You put all the data you're trying to consolidate in this one thing. Why is this important? Again, because this will help you decide whether you need to work with NoSQL or not. Think about this. Oh no, I'll discuss this. I think I have a slide right somewhere. Yeah, I have a slide afterwards that will explain this more in details. This is the third type. It's called column family. Big Table in Google is using this type of database. And this is simple. You can imagine it as something similar to key value. So remember key value, we have it over here, right? This is the key and this is the value, right? Now, in column family, what you have inside the row key is a family. So let's imagine a family named profile. What does it have? These columns. So all these columns relate to a profile, right? You can imagine a column family as its own child. It's something like a child to the row, but you still store it in one place. Okay? The good thing about this, it helps you aggregate data better than the document and key value, but still in the end, you're losing some of the performance gain you're getting from key store. It's still much faster than just inserting using or searching quickly using relational data. As a matter of fact, I remember this was, I think, yesterday or the day before. There was a new record number for sorting. Imagine trying to sort or read data as fast as you could. How can you do this? How can I read data really fast? Sam, bring a faster I/O. Again, no. Which will be faster? A very fast SAN or 1,000 machine each having their own data and searching through 1,000 machine. That one would be faster, right? So this is a system. There's a file system called Hadoop. How many knows about Hadoop? At least heard of Hadoop? No one? This might be, if you're interested, this might be a future session where I talk about it. Hadoop is like a system to store distributed data. And it works well with NoSQL. Because as I said, NoSQL is about more machines, right? So usually when you store this kind of data, you use a Hadoop kind of amount. Hadoop is the fastest, right now, the way to handle biggest data you can is using Hadoop. So the record I just talked about that was set up by Google, I think 2 days ago, it was something like 1.5 trillion byte in less than a minute. They used something like 20,000 machines to read as fast as they could from that. This is really fast. You can never reach this at the current time with relational engines, relational database engines, unless you're using a new technology called sharding, but still, it doesn't scale as fast as NoSQL, okay? So this is the column family. This is one example of a column family. So again, remember this. We don't use aggregates in relational. So instead of storing this is the aggregated form that we usually look at. We just store it in separate entities, and we search for these later on. The good thing about this way, again, is that you can aggregate as much as you like by using SQL, right? Remember the famous statement, you say select product and then sum or something. This is an aggregate, right? So SQL gives you really good flexibility with aggregating data. NoSQL doesn't give you that flexibility. So it's very easy, for example, to get, see, this is in NoSQL. You just put this order with everything in one place. Simple, right? The other thing, again, about it, remember I said two things. First, you're putting data in some, now you distribute data. It's very easy to distribute data now that everything is in one place. Right? I can put some of the data for these orders in this server, the other data in other servers, and so on. It's very easy to, it's cluster friendly. Again, it's really easy to handle data in that way. But if you're aggregating with a different way, for example, you saw the example we just talked about, order, right? Can you give me, some manager comes in and tells you, okay, I need the revenue per product. How can you do that? If it's database, it's easy, right? Run through products and aggregate through this other table, and it works fine. But if you think about it in document, let's say document way, each order contains the products inside it. So you have to go into each order and look, maybe you have this product and maybe you don't. So what you end up with is something like searching the entire thing, all data just to get this. This is really, this is not efficient, right? Does this have a solution in NoSQL? Yes. Because NoSQL usually, by the way, again, this is about Hadoop. If you're working with Hadoop, they end up creating something called MapReduce. It's Java. You can create jobs, code, that goes through the data, gets the data you want, and then stores it somewhere so you can aggregate based on it. So it works, but again, it's not a natural thing. It's not a thing that comes out of NoSQL. You have to work with this. So if you're thinking about data, which you usually aggregate in few ways, NoSQL is the perfect choice. If you have data that you need to aggregate always from different angles, then you might think more about this. Okay, so again, with the SQL databases, you don't have this issue. Product, line, and it works. It's easy. I don't have to think about this. The types we talked about can be grouped into this. See, the column, document, and key value, we all call them you call them all as aggregate oriented, right? Because everything you store is like in one thing. All of these three. There's one more type called graph. Graph is totally different. It's a different type of NoSQL. I think, have you heard in Facebook the new graph search?
Yes.
It's actually using this.
Like notes.
Exactly. It's this. The idea in graph is it's the other way around. In relational engines, I mean, how do we go to NoSQL? We aggregate, right? We put more data in one place. Graph, you do the opposite. You break data down into smaller parts, and you design them in a different way. You need just an entire session just to explain to you exactly how graph works. But the idea is something like this. You can imagine it as in like Facebook. This guy has friends. This guy has employers. It's all based on relations between the entities inside. But to give you an idea, this is a good example on how graph works. So if I need to know about Barbara and who are the friends for Barbara, I'll use some code like this. Give you 20 seconds to read it. I think it's simple, right? Just tell me which node is Barbara, and then give me all the friends. And just a second, I think I need to remove this part. Give me the name and the location. So this is kind of give you a good example on what graph databases are. Do you know the most famous one for graph? Neo4j. You'll hear this term. I mean, in graph, it's clearly the winner so far. It's the best graph database. Okay, so it's a totally different way of handling data, but these all two groups share the same thing. They all work without schema. You can define any schema you want the way you want. Now, the next concept I'm going to discuss here is the consistency of the problem with consistency with NoSQL. Because this is the general concept, just quickly. RDBMS support ACID. Do you guys know what ACID is? You should. Anybody who works. Atomicity, consistency, isolation, and duration. Durability, sorry. Durability. So basically, transaction stuff. This is the easiest way I can explain it for someone who doesn't know it. Supporting transaction in a consistent way. If you're in a bank and you're trying to transfer data from an account, you don't want to lose some money in the process, right? The total has to always be the same, before and after, right? So relational engine supports this in a really good manner. NoSQL doesn't. Because it works on a totally different concept called base. I always have problems remembering what base is because it's a really bad way of naming it. It's basically available soft state eventual consistency. Basically, it boils out to something like this. I'll explain it to you in the next slide. The most important factor for it is eventual consistency. Data will eventually be consistent. Because remember, what is the use of NoSQL? Because of large data, right? So my concern is I want to store data as fast as possible. I'm willing to sacrifice consistency as long as I can store fast enough. Eventually, I will make sure that data is consistent. Remember, we're talking about thousands of machines, right? So if I'm storing stuff here, this needs to modify some data in another server. So that data will be consistent. I will not wait. I will continue with other operations, and afterwards I'll do some jobs or stuff to make sure that the data is consistent. But it's not consistent at the same time. Now, from this you can immediately imagine this will never work with banking. Right? So this is why I'm saying it's not going to replace relational engines, it's just going to complement it. They will work together. Some areas that RDBMS won't cover it, NoSQL will. So, this is a misconception because everybody will tell you, you'll hear this again from many people when you ask them about NoSQL. NoSQL is not ACID. This is not true. Aggregate-oriented are not. These guys are not. But graph databases are ACID. Think about the concept. By the way, this is not a flaw in design. Because in aggregate-oriented, remember, the document is the order, right? So it's designed, so if you have transactions working with this order, it will work well. It does support ACID in its own area. But if you go out, it will not support that. So if you're really aggregating data in the right manner, you shouldn't worry about this. Right? Because I'm doing everything in the same place. I should only modify data in the same place, not outside. Graph, why is it important in graph? Because remember, graph is breaking stuff more than even relational. So I will be modifying many parts at the same time. So I need ACID for that. So remember, it's not like, oh, this is a flow. It's the way it's designed that tells you about this. So a quick discussion about consistency. You're all familiar with this. If you have two users trying to access a server, of course they're using the browser, and then they reach a server, a web server, and then the database, right? So if you want to get data, read data, this is not an issue. Anybody can read at the same time, right? But if you're trying to modify data, you might have an issue for the overlap. Both of them are trying to modify the same data. How will NoSQL work with this? Well, usually you have more than one option. One option is just to put everything in one big transaction. Is this a good idea? Imagine the user is clicking a button and you're locking everything as a transaction. No, nobody does this, right? There are examples of something similar. Like, for example, when you're booking through Saudi Airline, as an example, you know that when you choose a seat, it gives you like 20 minutes. The seat is reserved. So it's kind of like a transaction that is booked for you. Okay? But usually it's not this way. Usually what happens is you don't lock until the actual operation happens. Right? So you only lock the part for the for the writing, right? This is only what you... And even if you do this, there will be conflict. So one of them will fail and one of them will continue. And in relational database engines, usually you don't have a choice. It just fails. With NoSQL, you might have a choice by using what we call versioning, version stem. So what happens is something like this. The record has a version of 1, and if both of them are reading, they will read 1 over here, and this one will read 1. This one will modify first, so it will give 2. So when this transaction comes in and tries, it will know that, oh, the version is different than what I had. So at that time, at that point, you have the choice of what do you want to do next. Do you want to override this, or do you want to go back? Do you have any other way of solving it? Again, this is a normal way, and I think most of you have this idea. Okay, consistency. Again, getting back to it. How do you make sure that you have a consistent environment? Well, logically, by the way that you handle this, remember it's distributed, right? So do I put the data only in one place? Imagine this, I have 1,000 records. Do I just throw a record everywhere and then I have 1,000? This is one way of doing it. This is called sharding. Sharding means putting your data in separate places. But it's one copy, right? So if I lost this one, I lost the data. Usually what they do is some form of replication. So you put some of the data here, some of the same copies in different servers. So if I lose some of the server, I still can get the data from others. Again, this has to do with Hadoop more than NoSQL. Okay, the system that implements this. But just know about it that you have these choices available. The thing that you have to think about really careful with consistency, I'll give you a good example. Two guys, this is an example I got, two guys are trying to book a room in a hotel. So what usually happens is, one of them wins and the other one just will see that I can't, and somebody booked it already. And this is how it usually happens. But remember, right now we're talking about distributed data. So the data is in separate places. Imagine a guy from the US and a guy from here, from Saudi Arabia. They're trying to book. And some of the servers are offline. 300 servers are offline from the 1,000. You will start getting consistency problems, right? What do you do in this case? If I cannot access the servers that gives me the actual, whether somebody has this room or not. Because remember, if he books the room, it could be in this server, in the 300. And I don't know because I'm in the area of this other 700. You will start having these issues when you work. So how do we solve this? Well, we have two choices. Choice number one is simply, if there is any disconnectivity between parts, I will make everyone fair. Right? Either all servers are online to do the operation, or I just cancel it. Does this work? Well, usually business people don't like this. What they will tell you is, in the example of the room, no, I would prefer that each of them book the room. I'm okay with this. You will ask me, okay, so I don't think they will really share the room. What will happen really is, the hotel usually have some spare rooms, right? That what I'm trying to say is, I'll manage it. Just make them both book it, and I'll manage it. Worst case scenario, I'll just say I'm sorry, and I'll give him another hotel or another booking. So this is another choice for you. You have to think about this. Remember why? Because in the case of RDBMS, you either get it, both of you, or you don't. Here in NoSQL, I start having more choices and more problems as a result. So consistency here is your factor. Why did I decide to cancel both? Because I care about consistency. Right? If I decide to have them both, then I'm choosing what? Availability. Right? I want my application to be always available. Why am I saying this? This is a very famous theorem called CAP theorem, which means that pick two out of these three. Consistency, availability, and partitioning. Partitioning data, sharding, remember? Usually with relational engines, which two do we choose? Which two? In relational engines, which two are chosen usually? Consistency and? Right? We do have partitioning in relational, but it's not as good. It's not a complete thing. While with NoSQL, you have to choose, again, two. So you already chosen partition because it's distributed. Your choice is always to choose between one of these two. Okay? It's not really a 1-0 thing. It's not really an OR, because it's usually something like this. Right? It's not a true or false. Usually you try to get all. But if the case happens, which one do you lean to? Okay, this is an important factor again for deciding which way to choose. Some people might think of it instead of consistency and availability, they think of response time. You know what I mean by this? Think about Amazon. If I'm trying to buy a book, and this book is available in 30 places around the world. If I try to query all these 30 places, the response time will be very slow to the customer, right? So instead, I'll tell him, okay, I'll choose, for example, to give him faster response time, and I'm sacrificing what? Consistency, right? Again, for business. So it's not a matter of just connectivity or availability. Sometimes it's just a matter of response time. I want faster response, so I'll choose this. Okay, Facebook also goes with this. They care about, what's the consistency problem in Facebook? there is almost none, right? So I don't care, I just care about giving you data as fast as possible. These are the concepts you will be hearing about. Most important ones is, of course, relaxing durability, eventual consistency, as I said before, quorums, which means you have like a voting mechanism. So there's a certain number of servers you're willing to lose before you say, no, I'm not going to give you more than that. And stuff like read your writes consistently. And a matter, you can just think about it as this. Make your life simple and just go ahead with NoSQL. And that's why usually it's in big data without too much concern about consistency. So NoSQL has two main values for you. Large scale, Twitter, Facebook, Google. Once you have big enough data, you just have to go to NoSQL, at least for the time being. The other reason is easier development. You don't have to be, because some of you will say, I don't have that large of data, so I'll just use SQL, right? No, you might want to choose NoSQL if you want to get something out very quickly. And again, consistency is not a big issue. A good example is a newspaper. If I have a newspaper and I want to develop it, remember, newspaper in the end, it's articles, right? Isn't it like a document kind of ID and the article? Nothing more. So it makes sense to do a NoSQL application for a newspaper, right? If it's a transactional base, then no, you have to think more about this. And by the way, just to tell you something, the thing I'm not discussing here is that SQL also now, they are moving relational engines to support distributed data. If you worked with Azure, the cloud for Microsoft, they have a database concept called sharding also. You can shard the data across multiple servers. But again, it requires more work from your side. How are you going to shard the data? You have to do it manually. Put this data here, put this data there. So it's not as good as NoSQL yet. Okay, why is NoSQL working so well these days and object database engine didn't? Because of this, right? At the time it was integration database. But these days, it's not a good idea these days. Who uses integration databases as the only way of integration? If you want to integrate with another application, how do you usually integrate? Think. I have an application, I want to integrate with another one. What do I do? Web service. Web services weren't available at that time. But these days, they are available, which is why they make a better choice for integration. And it's not actually a best practice to integrate through database anymore. Okay, so if you have this, think of moving it to a web service kind of platform. Unless the two applications are really tightly integrated. If that's the case, you should think of having one application instead of two. Okay? So this is the reason why NoSQL is working really fine right now. Another example of why databases work so fine is how time? Sorry. So another example is data warehousing. How many of you have data warehouses in your companies? Exactly. The problem with data warehouses, it's too difficult to do them usually. Okay? And the other concept that people are working with right now is, instead of just building a data warehouse as a big thing, I build small parts. So, for example, NoSQL gives you good analytics. Remember graph database I just explained to you? it's really easy to build analytics out of graph databases. Okay, so don't think that Facebook is doing something really awesome with this. The engine itself supports this in a good way. So data warehousing and analytics are much easier with NoSQL. And by the way, the end result, data warehouses reads from many sources. You will be reading from RDBMS, text files, logs, graph databases, documents, and everything, and putting it in the data warehouse. But this is, again, a good start for NoSQL at that area. I'm not sure if this concept is going to work. This is a concept that Martin, the guy I just told you about, he's saying that this is the future. I know that it's the future. The future is not SQL or NoSQL. The future is a hybrid mix of both. Okay? So SQL Server or Oracle or whatever database you use, how do you store files? You have ways of handling it. But I can imagine in the future, for handling the files part, you could use a NoSQL. Okay? And already some of them, all major database engines are looking into these options, integrating both ways together. He called it polyglot persistent. I'm not sure if this is going to be the name at the end. But the concept, yes, is true. This is what's going to happen in the near future. So the reason, this is why it's more important for you to start learning about them. Okay? Learn more about NoSQL. This is what's going to happen. You will find some databases working with Neo4j, the graph database. It depends on what kind of application you're talking about. Remember, the newspaper sounds good like for a document kind of database. You should think about it in these kinds of ways. And actually, Twitter, for example, Twitter is running on all of them. Twitter is using MySQL for some of its data. It's using Cassandra for some other data. And other databases, FlockDB and stuff, which are NoSQL also. So a mixture. This is what's going to happen. Some of the problems, I can summarize the problems in this for me. Of course, it requires a big change in the way you think in the organization. So far, NoSQL databases are immature. You will still have many issues working with them. The database engines, the RDBMS, are for more than 20 years have been there, right? So they're mature enough. You know all the problems and you know how to work with it. It's not the same case with NoSQL. It's still a new technology, or some new technologies. So if the project is really important, you might think twice before using NoSQL. If it's a small project within the company, yes. Because remember, with NoSQL, again, the implementation could be faster sometimes, but depending on what you choose. Eventual consistency is an issue for some, as I said, like banking industry. So you have to think about this. If it's strategic and you have to develop it really fast, you have to, if that's the question, ask yourself, which one would be faster for me? If you don't have that knowledge of NoSQL, then it's of course faster to go with a SQL kind of database. But if you have a choice, like a simulation, a small application within your company, do that, try that. If it's data intensive, I don't think you will reach that. Because from my knowledge, about 95% or more even, of databases out there work with SQL just fine. It's for these small databases with the size so huge that yes, you need to go and find a different way. I mean, for example, if you're talking about Large Hadron Collider, if you know about it, the lab for physics and stuff, these guys are talking about collecting data at 1 petabyte per second. Can you imagine that? There's no way a normal database engine can do this. You have to use Hadoop and some other stuff with it. As a matter of thanking Martin for sharing with me this, I'm adding this book for him. It's like a 150 pages book, really small and really nice. Discusses a lot of things about NoSQL in a good manner. You might want to look at this book. Okay? And I think that's about it. You have any questions?
Yes.
Hmm?
No. A couple of years ago, I read something was written by the people who created Facebook about social databases.
Yes.
Okay, how the relational database doesn't fit in the domain of social interaction. And they suggested a graph-like database. Okay, so how far? This is another NoSQL?
Yes, it's called graph databases, and the most famous one is Neo4j.
Okay.
That's what they're using so far, and it's an amazing technology. If I would tell you just out of your mind, if there's no other factor to choose but just learning, you might want to start with this one. It's an interesting concept, the graph database. It's new for neo4j.org. Go there and at least look at the video, the introduction, to learn more about these kind of databases. They work really well with cases like Facebook. Facebook, I remember they published a video in 2010 explaining this. This was 2010.
This was like 2006 or 7.
No,
just publishing a paper talking about...
the paper. I saw a video about this in 2010. They explained their experience. They're using MySQL, okay? And they explained like why did they have to go to a NoSQL kind of implementation. You just see all the news from your friends, right? But you know where's this data? You're talking about collecting data from servers all around the world. If you're doing this in a normal relation engine, response time will be too slow. You have to distribute data. So there's no way to do it in a good way with relational. They had to implement at least part of it with other NoSQL engines like Cassandra and now, for example, the Neo4j. Okay? Any other questions? Okay, thank you everyone.